All right. Hello, everybody. Thanks so much for joining us today for this week's session of the Parks College weekly webinar series. My name is Amy Price, and I'm the outreach coordinator here at SLU's Parks College. I'll be joined today virtually by members of SLU's Center for Additive Manufacturing, who will be talking about 3D printing in the Biomedical Engineering program and at SLU. We're so excited to have you joining us today from wherever you might be. Thanks for taking the time to virtually visit us and learn more about the aviation and engineering programs at St. Louis University. In total, Parks College has programs available in aerospace, biomedical, civil, computer, electrical, and mechanical engineering, as well as flight science and aviation management and physics. We hope that you'll see or hear something today that piques your interest. Before we start, I did want to give you an idea of how this webinar will flow. In just a moment, I'll introduce Dr. Scott Sell, who will begin a tour of the SLU CAM space and introduce other faculty members and students along the way. Throughout the webinar, we do encourage you to submit any questions you may have to the Q&A feature at the bottom of your screen if you're viewing through Zoom, or in the comments section if you're viewing through Facebook Live, and we'll do our best to answer those questions during the last few minutes of our session. Throughout this webinar, you don't need to worry about turning off your microphone or your camera. You can hear and see our presenters throughout the webinar, but we cannot hear or see you. Finally, if you do have any technical difficulties during the webinar, please send us an email at parksevents@slu.edu, and we'll help to address any issues that arise. This session is being recorded and will be posted to our YouTube page in the next day or two, and you'll receive an email with that link when it becomes available. If you would like to view any of the webinar recordings from our fall 2020 semester, you will also find those recordings on our YouTube page. So now, with that introduction out of the way, I am very happy to introduce SLU's Center for Additive Manufacturing. And Dr. Sell, I will hand it over to you now.
Hello, we're really excited to share the SLU Center for Additive Manufacturing with you all today. I am Dr. Sell. I am the program coordinator for Biomedical Engineering and part of the leadership team here for the Center for Additive Manufacturing. We also have Dr. Scott Martin, who is the chair of chemistry and a member of our leadership team, as well as Dr. Andy Hall, who is part of the leadership team and the director for the center. So we'll let Dr. Hall talk about what we have here at the Center for Additive Manufacturing.
Good. All right. Nice to see you guys. Well, I'm not really seeing you, but nice of you to be here. So, okay, this is the building that you're looking at now, or the room you're looking at now is the new Center for Additive Manufacturing. It was established through a grant from the Office of the Vice President for Research through some donations to the university. And so this gave us about 1,000 square feet in the brand new interdisciplinary science and engineering building. So we have this large work area here. We have cleaning stations, we have offices, and we also have a student work area. So we employ 3 student employees. So that's sort of who we are. We have, let's see, let me go over here. Our main resources are 2 state-of-the-art industrial 3D printers. We have 6 in total and some other equipment, which I'll tell you about. But let's look at the printers quickly. The Stratasys J735 is a technology called PolyJet. What it does is it's a polymer printer. It prints sort of like your inkjet printer, except in 3D. And so it builds it up layer by layer, like other 3D printing technology. But this is full color, and it can also print clear material. So you can see this model of the brain, which has been scaled down, but all the anatomical components are segmented and have different colors. Here is actually, this is a 3D print of SLU CAM itself. So we took the architectural drawing and scaled it down and printed it. Here's this thing's kind of silly, but this is a full color lollipop, not edible. Here's another model that we've done. This is a human hand, of course. The other thing that we can do, so we can 3D print from a CAD drawing, right? Computer aided design. We can 3D print from medical images. These are from CT scans that have been segmented. We can also just define anything we want. And so this object was created just by going into a computer program and defining each individual voxel in the print. So we can have arbitrary designs. You don't even have to be able to design it on a CAD program. So very, very flexible. Our other printer, I'll put this in a minute, our other printer This is not unlike printers you may have at school. This is FDM technology, right? Filament deposition modeling. And so it is extrusion. It extrudes one material. It's actually, yeah, just getting ready to work now. And so these are the kind of objects that it prints. You can see that. So this was from somebody in the art department. They eventually want to print this full size, so 6 feet tall, but we started with this model. You can print entire assemblies at one time. So these things were not put together, but rather printed with another material called support material that just dissolves away. And what you're left with is an entire assembly. You can see this is a ball bearing assembly. This is actually an entire spring wind-up car, and it was printed as a single object, right? With the support material just melting away. You can even print things like, yeah, kind of 3D printed fabric. Here's another. There's a dinosaur skull. We even did some research during the COVID crisis on 3D printing masks. And so what's interesting about this particular mask is we scanned people's faces and we made a custom mask that fits exactly to an individual's face. Okay, let's see. We also have, over here, other technologies that we have are laser cutters. So laser cutters cut flat stock material like plexiglass and wood. Laser cutters can do a couple of different things. They can engrave. So you can see here's our SLU Cam logo, and some areas are darker, some areas are lighter. And so you can engrave objects with different intensity, but the laser cutter can also cut clean through it, which it did here on the outside. So you submit a program to the laser cutter telling it what to do, and it just goes and does it. So we have a couple of different of those objects. We also have, all of you know what a 2D page scanner is, right? Where you just slap it on the scanner and you get an instant copy of your document. We actually have a 3D scanner, so we can scan, as I mentioned before, your face. We can scan an object, and so it's a handheld device that you move around the object, and you take a huge series of pictures and reconstruct that into a 3D surface, and then that can go into a computer, and we can 3D print and do other processing on that. So have a lot of resources here. What do we do? So our primary missions are support research at the university and education at the university, engineering students and others. But the center is available to anyone from the community. So anybody can walk in off the street with a design, and we're happy to print it for them or for you, actually. And you don't necessarily even need to be a CAD expert. So we have people that come in. We had an entrepreneur come in the other day. He was trying to make an object, and all he had was a sketch on the back of a napkin. Well, we can take that. Our students know CAD. They can create a CAD drawing, and then we can 3D print it. So you don't necessarily have to be a CAD expert. You just have to have an idea of what you want to do. Oh, and a little bit of cash for people coming in off the street. So what I'd like to do now is have you talk to a couple of students who are employees about some of the stuff they've done. So I think we'll start with Alex Seepy, who is right here.
Hey everyone, as Dr. Paul said, I'm Alex Seepy. I'm a senior biomedical engineering student here at SLU. I actually got started here a couple of summers ago, in the summer of 2019. This is back before we even had a dedicated space here, before we had a research grant. All we had was the Tinker Lab over in McDonnell Douglas Hall, the engineering building. And I got started there just working as a summer job with Frank Coffey, who works with a lot of the aerospace equipment over in Oliver Hall. But what a lot of that job entailed was learning a lot of the machines over in the Tinker Lab, learning how to set up the laser cutters. We played a lot with the Glowforge, which is our Wi-Fi based laser cutter. We had the Fortis 250 and one of our Polyjets at the time, and then we got the 450 later that year. And then after the COVID pandemic hit, and we came back for school in the fall of 2020, this new space, this beautiful space was set up, and I was able to come back, take right where I left off. And the biggest experiences here that are great for career launchers were basically learning CAD, learning 3D printing, which are obviously huge skills that employers are looking for right now. And it's just been a good opportunity to learn and really become proficient with some of those and just meet some really cool people and work on some cool projects. Like we recently worked on a project where a biology professor wanted to have a lot of samples of this dogfish shark skull, but instead of ordering a lot of them from online and paying for them, we just had them perform a CT scan, where we could obtain a CT scan from the dogfish skull and then turn that into an STL and 3D print like 24 copies of it. So that was just something really cool that we did.
All right, and I think we have one other student on the call, Monica Schuler. Monica, if you want to, there you go. Just talk to us about your experiences and your research and the work that you've done with SLU Canada.
Well, hi everyone. As Dr. Sell said, my name is Monica Schuler. I am currently a graduate student in the Biomedical Engineering program here at SLU. I got interested in 3D printing. Well, within the field of biomedical engineering, I am interested in 3D printing, medical imaging, and tissue engineering. And that is what my graduate school, my thesis project focuses on. So what I do is I take models of, okay, well, we can talk about different things. I take models of, take CT scans of patients with cleft palates and import those images into this program called Mimics. And then from Mimics, I can render out a volume defect of the cleft lip. And then I can use the Stratus printer, the J735, and I can print that defect, the patient-specific defect. And then I fill that with a tissue engineered scaffold. And then hopefully that will eventually be able to regrow bone and do away with the need for bone grafts. So I also work at the center. And so we help people, as Dr. Hall was saying, we help people with their design. And you can come on in with any idea, and we are more than willing to give you our input on it and our take, and then have a functional model for you. So.
We also do a lot of collaboration. Alex pointed out that we've done collaborations with with biology in the center in the School of Arts and Sciences. We also do a lot of work with chemistry. Again, one of our leadership team members and founders is Dr. Scott Martin. We can talk a little bit about what we do with chemistry.
Sure. So yeah, it's a good segue. Like, why are chemists involved with 3D printing? Well, the lines between scientific disciplines have really been blurred over the last 10 years. And there's more and more interactions between chemistry and engineering, specifically biomedical engineering. So I've been doing research in an area of microfluidics and lab-on-a-chip systems for about 15 years now. And we used to make these technologies with a variety of different techniques. But 5 years ago, we got more and more to 3D printing. So how can you print miniature analytical devices to make measurements? The term sensor gets used a lot. We're trying to basically develop sensors that can do the whole range of analysis, from fluid transport to analyzing something with electrodes that we can embed in these devices, and to look at cell-to-cell communication pathways by measuring neurotransmitters. So we basically trying to design in this lab totally encapsulated devices that have all the functions to do those measurements. Right? So it's bringing a lot of disciplines together: chemistry, analytical chemistry, biomedical engineering, cell culture. We do a lot of things that we all work together on. I'm not the only person in chemistry that's thinking like this. We have other people doing more microfluidics from a corrosion battery standpoint. We have people doing printing structures to look at how proteins and DNA fold, how inorganic complexes get made. There's a wide variety of chemists involved with 3D printing. The cool thing about this lab is we're trying to bring a lot of people together from multiple disciplines. We've been working with dental programs to think about how to work with them. So that's kind of the whole goal of this building that we built here, $50 million research building and teaching building. And also this lab is to bring these disciplines together to really think about multiple approaches to solve scientific problems.
So I guess we'll open it up to any other questions that may pop up.
All right. I'm not seeing any questions yet, but if any of our viewers do have questions, please submit those to the Q&A feature through Zoom or through the comment section on Facebook. I have a few questions for you guys. Okay, so I have not been on campus this year, and this is actually my first look at the SLU Center of Additive Manufacturing. And one, really cool. So it's a room full of printers and people from a bunch of different disciplines. I'm wondering, what what does the future of 3D printing look like? It seems like there's so many different industries and disciplines from, of course, engineering and science, but now we've got art and perhaps archaeology or maybe historians can utilize this technology. So you guys are the experts. Where is this going?
Well, so two directions are, so to apply 3D printing more broadly into the disciplines that you mentioned, Amy. For example, we use LiDAR to scan the church image behind you. And so we took up, thank you, Alex. We took up a drone and used LiDAR to scan the church, and then we printed it. So speaking of its work in architecture, so there's many other disciplines we'd like to push 3D printing into, and that's why we're in the central location. But in terms of 3D printing itself, it traditionally started with plastic, right? Different kinds, and that's where we're at now. But there's a couple directions that are really starting to come to the forefront now. One of those is printing metal. And so there are some early technologies that actually print metal, and that's something we're paying very close attention to and will acquire at some point. Another huge area is called bioprinting. So the idea that you're printing either biological substrates or cells, something Dr. Sell knows more about, but that's also an emerging field in 3D printing.
Yeah, and I think if you look at a bunch of the different disciplines that we've worked with, you mentioned art and humanities. We've done work with the Center for Advanced Dental Education here on campus. And so there's a lot of different industries that as they move forward and start to understand the potential of additive manufacturing, I think we'll integrate that into either rapid prototyping or design or even testing and manufacturing of different parts and pieces.
Just add one more. I think scale is another important thing. So on both sides. So my lab, we're trying to push the scale smaller. So we print features that are under 100 microns. Then there's another discipline that's working on, we make big things, and like civil engineers print huge structures with 3D print. That's a big trend as well, like pushing the limits on either side of scale.
Awesome. This is so fascinating. Alex and Monica, I'd like to put you guys on the spot a little bit more. Everybody parts. Could you talk a little bit more about how you got involved and what you knew of 3D printing before you came to SLU and how that has now become such an integral part of your studies? Alex, if you want to go first.
I can go first.
Okay.
So the funny story is that I'd never actually done 3D printing before coming to SLU, but it was actually part of how I got interested in B&B in the first place, because it actually started when I think it was junior or senior year of high school. I can't remember. My mom handed me this magazine. It's like, hey, check this out. It was a magazine from Tulane where they were like 3D printing like bone repair substitutes or something like that. And I just really thought it was cool, and I wanted to look more into it. And that's kind of how I got into biomedical engineering in the first place. Now, as far as how I got involved in the center, it was the end of my sophomore year, spring 2019, and Dr. Bledsoe, who's the head of, who runs a lot of Parks College here, he's like the head of Parks College. He sent out a blast email to a lot of Park students that was saying, hey, Frank Coffey is looking for someone to work with him over the summer. And I had a few options, but I thought that sounded like better than like anything else I had on the table at that point. So I'm like, yeah, I'll take a stab at it. So I just took that opportunity, and I just once I got started with him, I started working in the Tinker Lab, which is what we had before this lab. And then I got really involved in the 3D printing from that summer, and I've gotten to use all of these machines here, which has been a really cool experience.
And then for me, I did not know anything about 3D printing before I came to SLU. Yeah, very minimal knowledge on that. And then I started taking my courses, and they would mention 3D printing in classes, and I'm like, and I've seen like about printers and stuff like that. I was like, this is an interesting topic. And then actually I took Dr. Hall's medical imaging class, and then he was like talking about how he uses 3D printers and his involvement in at SLU Hospital and working on cases there. And then I went up to him and I was like, hey, can I like get involved in your lab? And then I started working for him in his lab, and he has a whole bunch of like commercial, well, hobby grade printers there. And so that's where I first learned how to use like CAD. I taught myself Autodesk Inventor. That's the program you can use, or SolidWorks, to make your CAD models. And then I started printing there. And then as I got more involved in the research, I decided I wanted to pursue my master's. And so then we made a thesis project out of it. And so then I started looking for even higher grade printers that could be able to get to the dimensionality that I needed and the scope of my project that I needed. And then that took me to the J750. And originally I was printing all of my parts up in Michigan, actually, and they were sending it all down here. So then we bought a new printer for the center. And so they were like, oh, Monica's been working on these, but sending the parts elsewhere. So let's teach her how to use this. And then that pushed me into the involvement of the center, and then I started working there. So it was a big circle, I guess.
That's great. And I hear that the common theme from both of you is just being open to opportunities, and when it presents itself, you jumped on it. So it's so exciting. Congratulations to both of you. Okay, I'm going to bring the faculty back in if they would. So I love that you stressed that this is a center. This is not specific to one program at SLU, and not exclusive just to SLU students and SLU faculty. I understand that several teachers, high school teachers, middle school teachers might have access to 3D printers in their schools. Is there a way that they can connect with you, or is there a way that they can, walk in off the street to work with the center?
Yeah, they can do all of that. So first of all, we have a website, right? So www.slu.edu, I can't talk, /SLUcam, SLU-cam, which I'm sure Amy can make available. And so our contact information is there. There is a full-time lead engineer who's actually a chemistry PhD. His name is Andre Tasto. He runs the center day to day. So if you contact the center through the website, he will answer your email and fix you up with whatever you need in terms of 3D printing or CAD or anything. So yeah, we're happy to engage in that way. That's the way that you contact us. We're also anticipating some teacher education in the future. That's one of the goals in the center. So in the future, a teacher would be able to come here for a week and be educated on 3D printing.
Awesome. Thank you so much. All right, I'm going to put the call out for one more question. We've got a couple minutes. If you're on Zoom, feel free to put that in the Q&A feature at the bottom of your screen. And then if you're on Facebook, go to the comments. And I am wondering if Dr. Sell or Dr. Hall or Dr. Martin would humor me. And could you go show us your view? Can you see MDH from the ice building where you are?
Let's see. Maybe. Maybe way down there.
There we are. Okay, yeah, the green pyramid on top.
Yeah.
That's us. I just wanted everyone to see how close you are to the building that I'm currently in and the one that's on my Zoom screen behind me. So yes, the SLUcam is in our interdisciplinary science and engineering building, which is in the heart of campus, and really is a physical demonstration of how all of our disciplines come together in one space, and then also the physical reality of that. So, all right. Well, I think this is gonna about do us for today. Thank you all so much for taking us around the Center for Additive Manufacturing. A huge thank you to Dr. Sell, Dr. Hall, Dr. Martin, Alex, and Monica for sharing your time with us. And thank you to all of our viewers who joined us today. And we do hope that you enjoyed this virtual visit. And if you would like to learn more about the engineering programs at SLU, you can visit slu.edu/parks. And in our follow-up email, we will also send out the link to the SLUcam website and their contact information. So as always, if you would like to connect with us at Parks Further, please send us an email at parksevents@slu.edu. For any of our teachers logged in today, we'd be happy to set up another virtual lab visit or guest speaker for your class this semester. Just send us an email to get that scheduled. And a final reminder that in 2 weeks, on Thursday, February 25th, we will be hosting a virtual Introduce a Girl to Engineering Day from 10 a.m. to 12 p.m. So all students interested in learning about engineering are more than welcome to join us for that event. You can send us an email at parksevents@slu.edu to get registered for that. All right, so that includes our webinar today. Thank you again so much and have a great rest of your week.
Bye.